Hello guys, welcome back to my channel. So guys, right now the last test we conducted, we noticed we're having a little bit of delay. We used both this transformer. This is a 12 volt transformer, and this one is also a 12 volt transformer. So guys, what we did was to connect it to this rectifying diode. This is a KBPC 3510 rectifying diode, and we connected it to a capacitor. So we connected both transformer together, and each of the transformer was outputting 24 volts. So we tried to use it to charge back the system, but the motor was consuming a little bit more. But we noticed that whenever we connected at first we connected about 5 transformers together, which would give us a higher voltage. The aim was to get up to like 50 volts from the system to be able to power this DC motor. Remember guys, this DC motor is a 12 volt DC motor. But whenever we connect it to the system while the generator is running, we notice there will be a drag from the alternator. We connected this wire from the alternator, and this alternator was able to power back this transformer, because this transformer uses AC power to power it, then convert it into DC. We notice anytime we connect this transformer, the current do drop down. So guys, I'll put a clip to that about that video, so guys, you guys can see the way it dragged down the voltage from the generator system. So right now we have multiple transformers right here. We have about 5 transformers, and each of these transformer can output around 12 volts. So guys, 5 times 12, that will give us around 60 volts. You can see they are both connected to this rectifying diode. Guys, we're going to be starting it up with the switch. So guys, you guys see the way when we connected the transformers, the way it dragged down the current, even dragged down the voltage to the point that the light was very low. So for us to be able to rectify such issue, what I'm thinking of doing right now is to use a voltage regulator, which is automatic volt regulator. Maybe later on I will be introducing an automatic volt regulator, which will be connecting to the alternator, so that whenever we connect our multiple transformers, instead of it to drag down the system, the automatic volt regulator will be able to boost the current to be able to give more power to this transformer, so that the transformer, it's going to have constant power, because the main aim is for these transformers to have constant power, unchanging power, because when they have constant power, the output voltage will remain the same. It will be able to power the DC motor as effectively as it's supposed to be. So the automatic volt regulator will be doing the whenever you plug in a load to the generator, the automatic volt regulator will boost that power whenever the generator goes down, because you've plugged something to the system. The generator will be able to send signal to the automatic volt regulator to boost the power up, and will be able to have constant power from the transformer to be able to power this DC motor as possible. So guys, and another thing I noticed is these rectifying diode were getting hot. They were getting warm. So one thing we can do about it, about this automatic volt regulator, is by using these PC fans. Yeah, we can use this PC fan to be able to cool this rectifying diode so that it can work very well. But later on, we're going to be using transistors, which are very effective. They have high power, high switching power. They are called active rectification when you use them for AC to DC conversion. And we're going to be using this PC fan later on to cool those rectifying diode, because it's best whenever they are in operation, they should be able to work cool. They're supposed to be cooling them while they're in operation, because whenever this DC motor is working, you know, you're trying to power these guys and you're trying to rectify the power into DC to power these ones, and at the same time you're charging the battery. So this is a smaller battery, we'll be upgrading it to a bigger battery. So while all that is going on, there will be losses, and these losses result from the heat that are being generated from the rectifying diode, the transformers. Even the transformers will be cooled later on. So those losses are is going to reduce the heat will reduce the efficiency of the system. So when they are working cool, that will help the system to be able to work as efficient as possible. So guys, later on I'll be introducing the automatic volt regulator we'll be using. You guys might have seen it before, but we'll be using it in the system. So that is what I noticed from the system. So guys, we're going to push this project further. I'll keep on doing more tests, and I'll tell you guys my findings. So guys, thank you so much. I really appreciate you guys tuning into my videos. So right now, let's just turn on the system so you just see it. So guys, even though we're still using smaller battery, it has much the generator has high efficiency, because we're just using small battery to power the system. So imagine when we upgrade it to a bigger battery, it's going to work as efficient as possible. For now, I'm just using small battery to be able to test the efficiency and see how we can make it work with a smaller battery. Then later on we'll be getting a bigger one, which we'll be using to power the system. You see the load testing and the rest. But for now, we're going to go for the automatic volt regulator later on, and we'll be doing more testing, guys. So thank you guys for watching, and I'll see you guys on the next upload.